In Massachusetts, the Electrical Code, specifically 527 CMR 12, mandates the use of three-prong outlets in new construction projects and during major renovations. However, the code does not stipulate that existing three-prong outlets must be upgraded to four-prong outlets. When considering whether to replace your current three-prong outlets, especially in a high-rise building, several factors should be taken into account. Firstly, safety is paramount. Four-prong outlets provide a superior level of grounding protection, significantly reducing the potential risk of electrical shock. In areas where grounding is particularly crucial, such as kitchens, bathrooms, and laundry rooms, it is highly advisable to consider replacing three-prong outlets with their four-prong counterparts. Secondly, consider compatibility. Certain modern appliances and electronic devices are designed to operate correctly only when connected to a four-prong outlet. If you have plans to use appliances that explicitly require grounding for safe and efficient operation, replacing the existing three-prong outlets with four-prong outlets becomes a necessity. It's also crucial to consider several recommendations. It is always a prudent approach to consult with a licensed electrician to thoroughly assess the unique electrical requirements of your building, as well as the specific needs of the appliances you intend to use. If you decide to proceed with replacing the outlets, ensure that you use only high-quality outlets that meet or exceed industry standards. Furthermore, strict adherence to proper electrical installation practices is absolutely essential to guarantee safety and prevent potential hazards. Consider the added safety benefits of installing ground fault circuit interrupters, known as GFCIs, or arc fault circuit interrupters, known as FSIs. These devices provide an extra layer of protection against electrical shock and electrical fires. Lastly, be mindful that changing electrical outlets within a high-rise building may require coordination with the building's management and potentially the engagement of qualified electrical contractors. They can provide valuable guidance and ensure that all work is performed in compliance with applicable codes and regulations. When dealing with electrical systems, a comprehensive understanding of grounding is essential. Grounding provides a low-impedance path for fault current to return to the source, tripping the circuit breaker and energizing the circuit, which minimizes the risk of electrical shock. A three-prong receptacle typically includes a hot and neutral, and a grounding conductor. However, older systems may not have a dedicated grounding conductor, relying instead on the neutral conductor for grounding. This can create a potentially dangerous situation if the neutral conductor becomes compromised. A four-prong receptacle, on the other hand, has separate conductors for the neutral and grounding functions. This provides a more reliable and safer grounding path. When evaluating the existing electrical system, consider the ampacity of the circuit. Ampacity refers to the current carrying capacity of a conductor, and it must be sufficient to handle the load imposed by the appliances that will be connected to the circuit. Refer to the National Electrical Code, specifically Table 310.15b16, for the ampacity of conductors based on their size and insulation type. Ensure that the circuit breaker or fuse protecting the circuit is properly sized to protect the conductors from overcurrent. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit, preventing damage to the electrical system and reducing the risk of fire. When replacing outlets, carefully inspect the wiring to ensure that it is in good condition. Look for signs of damage, such as frayed insulation, corrosion, or loose connections. If any damage is found, the wiring should be repaired or replaced by a qualified electrician. Pay close attention to the voltage rating of the outlets and ensure that they are compatible with the voltage of the electrical system. In North America, the standard voltage for residential circuits is 120 volts, while some larger appliances may require 240 volts. It is important to use outlets that are rated for the correct voltage to prevent electrical hazards. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by monitoring the current flowing in a circuit. If the GFCI detects a difference in current between the hot and neutral conductors, which could indicate a ground fault, it will quickly trip the circuit, cutting off the power and preventing electrical shock. GFCIs are typically required in areas where there is a high risk of exposure to water, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or SIs, are designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when insulation is damaged or wires are loose. SIs detect arc faults by monitoring the current waveform in a circuit and tripping the circuit if an arc fault is detected. SIs are typically required in bedrooms and other areas where there is a high risk of fire. When working on electrical systems, always follow proper safety precautions. Turn off the power to the circuit before working on any electrical components. Use insulated tools to prevent electrical shock. Wear safety glasses to protect your eyes. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. Electrical work can be dangerous if not performed properly. Ensure that all electrical work complies with the National Electrical Code, also known as NEC, and any applicable local codes. The NEC provides comprehensive guidelines for the safe installation and maintenance of electrical systems. Local codes may have additional requirements that must be followed. Obtain all necessary permits before starting any electrical work. Permits ensure that the work is inspected by a qualified electrical inspector to verify that it complies with applicable codes and regulations. Keep accurate records of all electrical work performed, including the date of the work, the materials used, and the name of the electrician who performed the work. These records can be helpful for future maintenance and troubleshooting. When selecting an electrician, choose a licensed and insured electrician with experience in residential electrical work. Check the electrician's references and read online reviews to ensure that they have a good reputation. Obtain a written estimate from the electrician before starting any work. The estimate should include a detailed breakdown of the costs for labor and materials. Do not hesitate to ask the electrician questions about their qualifications, experience, and the work they will be performing. A good electrician will be happy to answer your questions and explain the work in detail. After the electrical work is completed, have the electrician inspect the work to ensure that it is safe and complies with applicable codes and regulations. Obtain a certificate of compliance from the electrician, which verifies that the work has been inspected and approved. Keep the certificate of compliance in a safe place for future reference. Regularly inspect the electrical system for any signs of damage or wear. Look for frayed wires, cracked outlets, and loose connections. If you find any problems, have them repaired by a qualified electrician as soon as possible. Avoid overloading electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to a fire. Do not plug too many appliances into a single outlet or extension cord. Use power strips with built-in surge protection to protect electronic devices from power surges. Power surges can damage electronic devices and appliances. Keep electrical cords away from water and heat. Water and heat can damage electrical cords and create a shock hazard. Do not run electrical cords under rugs or furniture. This can damage the cords and create a fire hazard. Replace any damaged electrical cords immediately. Do not attempt to repair damaged electrical cords yourself. This can be dangerous. If you have any concerns about the safety of your electrical system, contact a qualified electrician for an inspection. An electrical inspection can identify potential hazards and ensure that your electrical system is safe and up to code. Regular electrical maintenance can help prevent electrical problems and ensure that your electrical system is safe and reliable. Remember that electricity can be dangerous, so always follow proper safety precautions when working on or around electrical systems. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. When evaluating the need to upgrade from a 3-prong to a 4-prong outlet for range, it's crucial to understand the specific requirements outlined in the National Electrical Code, or NEC. The NEC provides guidelines for electrical installations to ensure safety. Article 250 of the NEC covers grounding and bonding requirements, which are particularly relevant when considering range outlets. Section 250.140 specifically addresses the use of the grounded circuit conductor for grounding equipment. In older installations, it was common to use the neutral conductor for grounding the range. However, the NEC has evolved to prioritize separate grounding conductors for enhanced safety. The NEC requires that new installations of range outlets include a 4-wire system with a separate grounding conductor. This is because using the neutral conductor for grounding can create a potential shock hazard if the neutral conductor becomes disconnected or compromised. When retrofitting an existing installation, the NEC provides some flexibility. Section 250.30A allows the use of the neutral conductor for grounding under certain conditions, such as when the existing wiring method does not include a separate grounding conductor and when specific requirements are met. However, it's important to carefully evaluate the specific circumstances of the installation and consult with a qualified electrician to determine the safest and most code-compliant approach. If the existing wiring method does not include a separate grounding conductor and it is impractical to install one, the NEC may allow the use of the neutral conductor for grounding, provided that the neutral conductor is properly sized and connected. However, it's generally recommended to upgrade to a 4-wire system with a separate grounding conductor whenever possible, as this provides a higher level of safety. When upgrading to a 4-wire system, it's important to ensure that the grounding conductor is properly connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or other approved grounding electrodes. The grounding conductor must be connected to the grounding electrode system in accordance with the NEC requirements. It's also important to ensure that the range itself is properly grounded. This typically involves connecting the grounding conductor to the range's metal frame or chassis. The grounding conductor should be sized in accordance with the NEC requirements based on the ampacity of the circuit. When working with electrical systems, it's always important to follow proper safety precautions. Turn off the power to the circuit before working on any electrical components. Use insulated tools to prevent electrical shock. Wear safety glasses to protect your eyes. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. Electrical work can be dangerous if not performed properly. Ensure that all electrical work complies with the NEC and any applicable local codes. Obtain all necessary permits before starting any electrical work. Keep accurate records of all electrical work performed, including the date of the work, the materials used, and the name of the electrician who performed the work. Regularly inspect the electrical system for any signs of damage or wear. Look for frayed wires, cracked outlets, and loose connections. If you find any problems, have them repaired by a qualified electrician as soon as possible. Avoid overloading electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to a fire. Do not plug too many appliances into a single outlet or extension cord. Use power strips with built-in surge protection to protect electronic devices from power surges. Power surges can damage electronic devices and appliances. Keep electrical cords away from water and heat. Water and heat can damage electrical cords and create a shock hazard. Do not run electrical cords under rugs or furniture. This can damage the cords and create a fire hazard. Replace any damaged electrical cords immediately. Do not attempt to repair damaged electrical cords yourself. This can be dangerous. If you have any concerns about the safety of your electrical system, contact a qualified electrician for an inspection. An electrical inspection can identify potential hazards and ensure that your electrical system is safe and up to code. Regular electrical maintenance can help prevent electrical problems and ensure that your electrical system is safe and reliable. Remember that electricity can be dangerous, so always follow proper safety precautions when working on or around electrical systems. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work. Furthermore, understanding the role of the neutral conductor in both 3-prong and 4-prong systems is critical. In a 3-prong system, the neutral conductor not only carries the return current from the appliance but also serves as the grounding path. This dual function can be problematic because if the neutral connection becomes loose or corroded, the appliance's chassis can become energized, posing a significant shock hazard. This is especially concerning in older installations where the wiring may be more susceptible to degradation. In contrast, a 4-prong system provides a dedicated grounding conductor that is separate from the neutral conductor. This separate grounding conductor ensures that the appliance's chassis is always connected to ground, regardless of the integrity of the neutral connection. This significantly reduces the risk of electrical shock and provides a safer operating environment. When evaluating the existing electrical system, it's also important to consider the presence of any existing ground fault protection devices, such as ground fault circuit interrupters or GFCIs. GFCIs are designed to detect small imbalances in current between hot and neutral conductors, which can indicate a ground fault. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the power and preventing electrical shock. GFCIs are typically required in areas where there is a high risk of exposure to water, such as bathrooms and kitchens. While GFCIs can provide an additional layer of protection, they are not a substitute for proper grounding. In fact, GFCIs rely on a properly grounded system to function correctly. Therefore, it's important to ensure that the electrical system is properly grounded, regardless of whether or not GFCIs are present. When upgrading to a 4-prong outlet, it's also important to consider the size of the conductors. The conductors must be sized appropriately to handle the load imposed by the range. The NEC provides guidelines for conductor sizing based on the ampacity of the circuit. It's important to consult with a qualified electrician to determine the appropriate conductor size for your specific application. In addition to conductor size, it's also important to consider the type of conductors used. The conductors must be rated for the appropriate voltage and temperature. The NEC provides guidelines for conductor types based on the application and environmental conditions. It's important to use conductors that are specifically designed for the intended use. When installing the 4-prong outlet, it's important to follow the manufacturer's instructions carefully. The outlet must be properly mounted and secured to the wall. The conductors must be properly connected to the terminals on the outlet. The grounding conductor must be connected to the grounding terminal on the outlet. It's important to ensure that all connections are tight and secure. After the outlet is installed, it's important to test it to ensure that it is working properly. A qualified electrician can use a multimeter to test the voltage and continuity of the circuit. The electrician can also use a ground fault tester to verify that the grounding system is working properly. It's important to address the increasing use of smart appliances and energy-efficient devices. These appliances often have sensitive electronic components that are more susceptible to damage from power surges and electrical noise. A properly grounded electrical system can help to protect these appliances from damage. In addition, surge protection devices can be installed to provide an additional layer of protection. Surge protection devices are designed to divert excess voltage away from sensitive electronic components, preventing damage from power surges. Finally, it's important to emphasize the importance of ongoing maintenance and inspection of the electrical system. Regular inspections can help to identify potential problems before they become serious hazards. Maintenance can include tightening connections, replacing damaged components, and testing the grounding system. A qualified electrician can perform these tasks and ensure that the electrical system is safe and reliable.